All right, so we are going to talk a little bit about symmetry. So I want you to think about what symmetry looks like visually, and then we're going to kind of use some of that information to help us with determining whether a graph is symmetric just by looking at the algebraic equations. Okay? So we're actually going to hold off on looking at this first graph for a minute. I want you to think about this second graph. So if you notice we've got symmetry along this x-axis. So I want you to think about what happens if we pick a particular point, say this point, and think about what the y value is at that particular point. Then think about what the y value would be at that point. I want you to think about the fact that it was symmetry across the x-axis, and we are comparing y values. Symmetry along the y-axis. This is a graph that's symmetric along the y-axis. And I want you to think about, as an example, what the coordinates of this point would be, and what the coordinates of this point would be, and what the special relationship is between the x-coordinates on this particular graph. Okay? Really, it has to do with the distance out from that line of symmetry, doesn't it? So think about that. Here we have symmetry, but it's actually symmetry in both directions. It's symmetry over the x-axis and the y-axis. So we'll get to that. But let's talk just algebraically for a few minutes. So if we are looking at or trying to determine if a graph has symmetry across the y-axis, I want you to notice that what we're going to look at is, and what we're going to do is we're going to replace and put a negative x or an opposite of x in place of the x. And then we're going to look and see if when we clean that up or simplify, whether that gives us the same expression as we started with. So if we plug in y is equal to, in place of that x squared, if we plug in negative x and we square that, if we clean this up or simplify, we get y is equal to x squared plus 1, which if you notice, so what we're looking at is this equation once we've simplified, and that equation, and we want to compare the two, and if you notice, they are definitely the same equation. So yes, there is symmetry for this particular equation. There is symmetry over the y-axis. If we look at the second example and we plug in a negative or an opposite of x into that equation, that's a really messy x, and I apologize, then we find that what we're really looking for that second equation, once we clean it up, is y is equal to a negative x cubed, or the opposite of x cubed. So these two equations are not the same. So we would say that there is not symmetry over the y-axis. So on a side note, I want to add in another term for you to become familiar with. If we have symmetry over the y-axis, we can say that the function is an even function. And we'll talk more about that in a later section. Okay? Also make a note about this piece of information. If an equation only has even powers, the graph will be symmetric with respect to the y-axis. So it means it will be an even function. Okay? All right, so just some good information to keep in mind. All right, onward. Let's talk about symmetry on the x-axis. And if you notice for that, what we are going to do is check by replacing y with the opposite of y, or negative y, to see if we get an equivalent equation. So let's plug in negative y, and we get x squared plus 1. If we're going to clean this up, we've got to divide by this negative 1. And if we do that, because we want to know what y is equal to, not negative y. If we do that, then we end up with the opposite of x squared, or negative x squared, minus 1. And once again, we are comparing this equation with this equation. And those are definitely not the same. So we would say that no, these are not symmetric over the x-axis. So let's take a look at this one. If we plug in the negative y equals x cubed, to simplify this or clean this up, we want to know what positive y is, so we divide by that, and we get y is equal to negative x cubed. And once again, we're comparing this equation with this equation, and no, we definitely do not have the same equation there, so we also do not have symmetry over the x-axis. Okay. Lastly, we want to determine whether or not a graph can have symmetry around the origin. And that's what this first graph was looking like, if you think about it. So I didn't specifically say it that way, but that's what it's referred to as symmetry over the origin. Another way of saying it is that it's symmetry across both axes, both the x and the y axis. So if you notice, we are going to replace both x with negative x and y with negative y. So we would replace our y here and our x, and I need you to notice that that negative x is going inside the parentheses, and that's getting squared. So if we clean this up, then we still get a positive x squared plus 1. We divide by this negative 1, and we get y is equal to negative x squared minus 1. And so when we compare this equation and this equation, we see that those are definitely not symmetric across the origin. Last example, let's take a look at this. If we plug in a negative y and a negative x and we cube that, if we cube a negative number, it's going to stay negative. So now if we divide by this negative 1, you find that indeed we do get, if you notice, we do have the same equation here. So yes, this particular equation is symmetric around the origin, or with respect to the origin. It also means it is symmetric with respect to the x and the y axis. And I also want you to be familiar with another term, and that is the condition that we look for to determine if a graph, if an equation of a function is an odd function or